Good afternoon, everyone.
Good afternoon, sir.
Good afternoon. So let me share my screen. Is it visible properly?
Yes, sir.
Okay.
So the screen is not visible properly.
I'm sorry?
It's coming blur.
Coming
Not
blur again?
visible properly. Not visible properly, sir.
So some people say it's visible, but some
Yeah, it's visible,
Sir,
but
it is
in the
visible,
last
sir.
its last class just blur, coming blur.
Yes, sir, it is blurred.
So I use the same kind of thing for the MSc IT course, and they don't complain about this one. So I don't know what is the problem. So I teach a course in MSc IT also, and they don't complain that they have a problem with the blurriness.
Sir, last time you did the companion mode thing. So can you try that way?
Yeah, we can do that. It's just that I'm wondering why it is only required for.
Sir, I think you can try with by creating new link. Like I think because in other courses also the instructor, the professors are using the Google Meet, but we are not facing these issues. Like
Okay.
you can try by creating new link also.
Okay, and but see, my problem is you also face the same problem on Thursday's link, right? And today's link, and Thursday and today's links are different. So okay. Anyway, so how would I go about doing the companion mode? Open a new, and you said there was something here, right? Companion mode. In the link itself. Then I have to stop sharing here. Better?
Yes, sir.
Okay. All right. I think I already. Yes.
सर वीक में दो असाइनमेंट सर मैनेज नहीं हो रहा है.
वीक में दो असाइनमेंट मैनेज नहीं हो रहा है, बट एक असाइनमेंट लास्ट वीक का था ना.
Sorry.
One assignment that you were supposed to submit was from last week only, no?
पर सर अभी मैंने असाइनमेंट 2 चालू नहीं किया तो क्विज 3 आ गई. सर हो सकता है तो.
See, basically if you recall, basically what I'm trying to do is quiz is something that will allow you to practically implement certain things, right? So
like that thing can also be included in the lab. No?
No, so okay, so lab also have the lab assignments only. I can only give you the lab assignment, that is fine. But the problem will be that lab assignment problems are a little bit more complex, and the quiz problems are more geared towards just the just working on one particular topic which we are covering in the lecture. So so I guess everyone is saying the same problem, is it? Plus plus, what does plus plus mean?
Like yes, everyone is agreeing with.
Everyone is agreeing. Okay. Okay.
Sir, you can give us quiz as a self-study.
No, fine. I can give you that. I mean, that is not a problem. But if you recall, we also have 10% grade associated with quiz and class participation, right? So class participation, I normally consider as, let's say, your attendance and things like that. And then quiz will be, so, worst case, right? If you don't submit quiz, what happens? Your 10% of the grade is class participation and the quiz, right? So 5% will be your attendance and 5% will be your quiz. So if you don't submit quizzes, then you lose that 5%. That's all.
Sir, but we're just saying like every week quiz ke alawa, if you can, like you're saying quiz marks, so you could maybe do like a monthly quiz. So that would be, because it's not just that, because we have other courses, even every course has assignment, of course. So it becomes very hard to maintain with too many assignments, plus the quiz also.
Okay. See, I can say assignments are not necessary to be submitted. I can do that, right? But then my only, I guess, concern there is that if I do that, what will happen? People will not even work on the quiz assignments. And then the lab assignments are going to be a little bit more complex than the quiz assignments. And then people will say that we don't know how to do the lab assignments. Because you have not actually worked on the quiz assignments, the lab assignments will be even more difficult, because it is on sort of like, incremental to the quiz assignments. So if you have problems submitting it, you can submit late, it's okay. If you if you think that it's too much, I can even say that fine. I mean, we can keep it optional for submission. But my only problem is that I don't want anyone to then say that lab assignments are too complex because we didn't have any practical experience with these problems, and so we are not able to solve it. And the only way you will be able to do it if you are attempting at least the quiz problems, because the quiz problems are a little bit simpler in nature compared to the lab problems.
So, sir, merge the quiz problems with lab problems and say it like problems you should go through before attempting to lab assignment.
Well, that's why
lab assignment.
That's why I am putting the lab assignments all well in advance.
Means, can you make the quiz assignment optional? Because two submissions in means on a week something.
See, bottom line is, if we make quiz assignment optional, then the attendance will be 10%. Because that 10% grade is assigned to quiz and class participation both together.
Sir, we can increase the grading of labs and decrease the grading of quiz if we are making submission of quiz.
No, we can't make the change now to the grading scheme, because I've already submitted to the management. And I've already shared it with you all. So we cannot make a change like that. We can only say that, okay, if you want to make the quiz optional, then the 10% goes to the... We can't get best of all worlds, right? We have to be following certain rules here. I mean, we cannot make change left and right like that. So anyway, I think we are already 10 minutes over the time. So let's continue with the lecture. Yes.
Sir, this time, I'm not talking about previous time. This time the quiz was easy, but it was quite lengthy. We had to write so much. And so, can you make that the quizzes are very short, but also in between? If the frequency of the quiz is fine if the quizzes are short to write and they are finished very quickly.
Let us do one thing. If you all have problems with timely submission with the quiz, I will say that quiz you must submit, but you can submit it even after the deadline. Okay, and we will not deduct the marks for that.
Sir, but the load for the week would be same, no? Like if you are giving quiz every week, then the load would be same only for us, and we have many assignments other than.
Sir, the problem in this semester is like from Monday to Friday we have labs on every day in the afternoon time, and the submission for every lab is also there. So it becomes a bit hectic for us to do the two
Then
assignments. Like,
then the only option is that I will have to put 10% for the attendance. That's all.
Yes, sir, it works.
Also,
for
sir,
that.
we need to make notebook for one assignment also. That is also very active.
Sorry?
In one lab, we have to also maintain a notebook.
Which
So,
For other course.
other
yeah,
course.
I mean, so like I said, if you, so I'll put the quiz up, okay, and those who would like to try, please try it out. But then the 10% grade I have to still consider for class participation and quiz. So if if you guys are saying that it's too much for the quiz, including the quiz workload, then I'll just use 10% for the class participation, which is basically your attendance. Okay, all right.
Sir,
Okay.
there was another request. Sir,
You're going to discuss everything in the lecture, then we won't be able to do anything in the
sir,
lecture.
about the lab, it was a request like TAs are not helping much. Like they are telling you have to do it self. Then how we would learn? Like
Okay,
it is
so
it is lab are for self practice, but we need at least a little help from them.
okay, see, I will talk to them. I will talk to them about this one, but I will tell you that this particular course is a special course. I think I mentioned this in the introductory lecture itself. So what happens is that even most of the TAs would not have actually studied these areas. Okay, so I will talk to them. I'm not saying I'll talk to them. I will talk to them to see whatever they can help, they should try to help you. However, since they have also not studied similar courses, they are also probably having difficulty, right? So if that is the case, then I will ask them to ask me to join one of those web links, and if you have some difficulty, I will try to answer the question.
Yes, that's understood, sir. Like they were saying we can't help. Sir has told no for helping us. They were saying directly that. That's why
No,
we
help meaning, see, if you're asking to find the answer, then I've asked them not to help you.
Yes, sir, we were trying for an hour or 1.5 hours in the lab, and then we are not getting. Then only we are asking so for a little hint or something.
I'll talk to them.
Okay, sir. Okay, sir.
Okay, let's proceed. I think we are already 15 minutes into the lecture. Okay, so basically what we covered in the previous lecture was about the GCC steps that the GCC tool follows in order to generate your executable file from the source files, right? The C file and the header files. So we follow, so GCC follows these 4 steps: pre-processing, compilation, assembling, and linking, right? Those are the 4 steps we looked at. Now, we said that we took help of one of the standard library function, power, right? And we also had seen how to link the library at the time when you are generating an executable file, because the library is not by default linked with the linked at the time of the linking step, right? So that was a standard library function or a standard library that we linked, which was the libm.so, right? But in this set of steps, what we are going to do is we are going to create our own library. Okay, so you could implement your own functions.
Sir, can you begin the recording?
I didn't. Okay. I thought I had. Oh, one second. Okay. Okay. So basically, you can create your own library with the whatever functions you want to include in that library. Right now, there are two types of library files, and I think I briefly mentioned that. So one is called static library. So static library has a specific extension, right? So how do you recognize the static library versus the dynamic or a shared library? The extensions are different, and of course, the way you create the library files are also different. So for the static library, any Unix-based operating system, whether it is Linux, whether it is Ubuntu, all of them will follow these two extensions. So .a is the extension for the static library, and .so is the extension for a dynamic library. Sometimes for the same functionality, you could have both the library functions also available. So for example, if I do locate libm.a, you will see that there is a static library file also available at this path, right? And I can also find SO, and you can see that at the same path, there is also .so file. So there is a static library for the same functionality and also the dynamic library for the same functionality. Now the question is, what that you would see in your Windows operating system, and these are the ones which are for the Unix-based operating system. So primarily, what is the difference? The difference primarily is that there are two major differences. One is that when you use the functions from the static library, okay, what will happen is when you create an executable file, the code of the function, the object code of the function will be copied from the static library file, and it will be included or embedded inside the executable file itself. Okay, so for example, you have one static library file, and it has a function called add. Let's say you are adding two numbers, okay, and that add function is being called from multiple C files, right? So let's say you have three different C files, and each of them is calling this add function. Each of these three files, when you create an executable from them and you are using the static library file, then each of those executable file will contain a copy of that add function code in it. So you are kind of taking the code and replicating in each of the executable file. Okay, so what happens is that the executable file size will be increased, right? The size of the file, the executable file will be more, right? But because the code is inside the executable file itself, when you run the executable file, it runs faster because it doesn't have to search where the function code is available. Okay, so basically what we are saying is it is called compile time linking, static linking, right? So you are linking the object code of the reference function at the compile time. It is a static linking. So the advantage is the running time is little bit faster, but the disadvantage is it increases the size of the executable. Whereas when you use a shared library or a dynamic library, what happens is that the function code, the actual function object code is not included in the executable file. Okay, there is only the reference to that function is mentioned, meaning it will basically say that in which part of the memory that function will be available. Okay, so it is not actually included in the program executable code or program object code, but there will just be a reference saying that at this location you will find a function. So what will happen is that when you try to run the code, and if the function is not available in the memory, it will have to search for that library file on the disk. It will have to load that library file from the disk to the memory, and then it will have to run that function at that particular address. So the advantage of the dynamic library is that the executable file will be smaller in size, because you are not embedding the function's object code into the program code, into the program's object code, right? But then it may increase the running time of the program, because at the time of the function call, it will have to figure out whether this function is already there in the memory or not. If it is not there in the memory, it will have to search for that dynamic library file, load it into the memory, and then execute that function code. Okay, so therefore we are saying that it is basically linked at runtime. That is why it is called dynamic linking. So here what will happen is why it is called a shared library, because the code of that function, if there are 3 executables who are using the same add function from the shared library, then all of them are just having an address referring to the memory address where the function code is available, right? So it will be the same function code loaded only once in the memory, and all these 3 executables will be calling to the same memory address to execute the function code. So this is the difference between the static and the dynamic library. So now what we are going to do is we are going to create our own static library. Okay, so let's say I have 2 files here, add.c and sub.c. Now you could include multiple functions also in a same C file, or you could have multiple C files also. I use multiple C files so that I can show you that you can even create a library file using multiple object files, right? So we have an add.c file and we have sub.c file. Out of this, we are going to create object files first in order to create the library file. Okay, so first we compile the code and we just follow the first 3 steps, which is your pre-processing, compilation, and assembly, right? So gcc -c add.c sub.c. And when you look at this, you will basically find that there are 2 object files created. Now, in order to create the library, the static library file, we have to use this command AR. So AR command is nothing but it takes the multiple object files and it creates an archive. So AR command is nothing but an archive command. So it takes the multiple object files and creates the archive, right? And that is the thing that we do, and that we use we use 2 switches, R and S. So R says insert the file member, right? And S would be add the index to the archive. So basically functions index will be added and the insert the object code, right? So those are the 2 options that we will be using. So we say AR is the command, then RS, and then we have to say which file we want to create, the library file name, right? Now in the library file name, as you can see, we are saying lib mymath.a. So .a or extension obviously is for the static library file. Lib is always generally used as a prefix, okay? So this is like a prefix that you give it to all the library files that you want to create, whether it is a dynamic library or a static library. And there is a specific purpose for that, which I'll come to that when we learn the linking step. And this is the name of the library file, basically, right? So my math is my math library. I'm creating my own math library, right? So this is the library file I want to create, and I want to use these 2 object files to create that library file. So that is what I'm going to do. Lib mymath.a add.o sub.o. And now that library file is created. So this is my own static library file. And this static library file has nothing else but the object code packed into from these 2 object files, okay, which contains these functions. Now, how do I use this library file? So obviously there has to be some main program which is calling the functions from these object files, right, or from this library file. So what we have to do is we have to obviously create a main function. So there is a main function which is then calling these add and sub functions, and these functions are actually from the library file. And in order to do the forward declaration for these functions, I've included the header file here. So mymath.h is the header file that has been created. Mymath.h, right? So this is the header file. Which has these two forward declarations of these functions, okay? And those are called here, right? So now, because I have the header file included, it will expand these two forward declarations in my C file in the pre-processing step, and at the time of linking, it will take the object code from that library file, which I will provide for the linking step, and will include that object file into my executable file because it is a static library. So first of all, obviously, I need to again compile this main program. So in order to compile the main program, I am again going to do gcc -c call .c. And so it will create an object file for the main program, right? Now, once I have the object file for the main program, I can create an executable by saying that this is my main file, and then this is the library file where the functions are included. These functions are called in my main program, right? So the linking step, in order to run the linking step, you know that we don't, as long as we provide the object file directly to the GCC program, it knows that the first three steps are already done. It is not required to be done, and we can just directly use this object file to create the executable. So that is what we will do. So we'll say gcc -o call function, and then I'm going to say static.out, because this is my this is the executable file that will be using the static library function, right? So I'm going to say static.out, and I can say lib mymath. Sorry, first I have to give the object file which I want to use. So I'm going to say function.o, and then the library file which has my functions in it. So this is going to just run the linking step, and it's going to create my static.out with the main program's object code and the library file. Okay, so you can see that there will be an executable file created here, and I can directly run that executable file that will do the addition and subtraction. Okay. Now, as you can see in this executable file, I don't have to provide where the library file is because the code from that function is already included in it. Now, I will show you the disassembly of this one using that obj dump command, which we learned in the previous lecture. So I'll do that for the static and the dynamic so that I can show you the comparison between those two files. Okay, so first let us create both the executables using the static and the dynamic library files, and then I'll show you the disassembled code for that. Okay. So this is how you would create the library file, and this is how you would create your executable file. Now there is one more thing that we need to learn when we use the library. So there are two other switches that we can use. If you just know the name of this library file, right, but you don't know whether the static file is there or dynamic file is there, right? If you don't know that, or if you don't want to also provide the full path, here you have to provide the full path, right? We didn't provide the path because this particular library is in current directory only. But if you would have included, let's say, math library, then you would have to provide the complete path. Okay. So in this case, we didn't because it is in the current library. Okay. Sorry, current directory. Instead, if you want to actually search the library file using just the name, right? You know, it could be the .so file or .a file, then you can just use a minus lowercase l. So lowercase l switch basically says that, okay, give me the name of the library, which in our case is my math, because the lib is the prefix. As I mentioned, lib is always used as a prefix. So when you provide my math, then what it will do, this minus L switch will preamble the my math with the lib word, right? So it will basically add the prefix, and then it will look for any one of the file starting with .so. So it will say first I will look for .so file. If it is found, then I will use the .so file. If the functions from the .so file, so I will do dynamic linking. But if the .so file is not available, and then it will look for .a file, and then it will do the static linking. Okay, but in our case, we specifically want to link the static file, so therefore I've actually directly given this whole path, whole file name. Okay, because in this case, if the dynamic file is available, then it will first link that one, and I don't want to do that, so therefore I didn't use this particular format. But when you use this format, you basically can also do the linking using the same thing. If the .so file does not exist, then it will link the .a file only. Now, when you do this, by default, it looks for library files in specified system library path. Okay, so operating system has a set number of paths where it looks for the library file, but that path does not include the current directory. So you want to say that you want to also search for this library file in the current directory. For that, we use a capital L switch. So capital L switch says that look for the library file in this directory also. Okay, so we look for the library file in the current directory, and then we give the name of the library file and then the object file, and that is what it will also use to link the file. So we do have a SO file. So what I'm going to do is I'm going to remove that SO file because I created it a little bit earlier. So we don't have a SO file anymore, right? So I'll say libmath my math, right? So there is only a file now, right? It doesn't, we don't have the .so file. It's only one file. So now if I use the same format, it will only link the static library file. Okay, so let me just use that format. When you copy it from it is using some different character for this hyphen thing. So I have to change it every time. Right? So you see that we can actually do the compilation exactly like that, even using this lowercase minus L switch. Okay, and this basically says that look for this library file into the current directory also. Okay, and so it is not going to complain. If you don't provide that capital minus L switch, it is going to complain. It's going to say that it could not find this particular, library. Okay, so that is what we have to do. So this is how we create the executable file using the static library. Now, how do we create the dynamic library? So the dynamic library, the way we create the dynamic library is using again a GCC compiler, of course. But then when you create an object file for the from the source where your library functions are, right? So add.c and sub.c is where we have the library functions, from where we want to create the dynamic library file. Now, if you recall, I just said earlier that when you create a dynamic library or shared library, the function code is not sometimes loaded into the memory until the function call happens. And the code of the function is not embedded inside the executable code. So what happens is we need to actually tell the GCC tool that the object file that I'm going to create from here, the address of this object file should not be independent, should not be dependent on the address of the executable code, right? So the executable code should have a different memory address range, and this object code should have a different memory address range. And in order to do that, we specify this option called -f with PIC. PIC here stands for position independent code, right? So basically the address is not dependent, is what we are trying to say. Position independent code. So the executable code position in the memory and the object code for these functions in the memory are independent, right? So both are not dependent. So this is what we have to use to create the object file for the dynamic, dynamic library functions. Okay. So GCC -f PIC -c add.c sub.c. So again, it will create an object file, but these object files will have the position independent code, the object file of position independent. So there will be some sort of information here that will tell the GCC to not use these addresses in the executable file, right? That is what it is telling. Now, in order to create the dynamic library file or the shared library file, which has an extension of .so, we have a GCC compiler itself, or GCC tool itself provides us a switch called shared. So the shared switch says that from this object files, I want to create my shared library file. Okay, so using GCC only, we can create a shared library file. So that is what we will do. So GCC -shared -o libmymath.so add.o sub.o. And this is going to basically create my .so file. So this file is the dynamic library file. And this file is my static library file with the same functions, add and sub functions. Okay. Now I'm going to use this dynamic library file to create my executable file. Okay. And in order to do that, the steps are pretty much the same. Okay. Whatever we did for the static library, similar thing we can do for the dynamic library also. There is no difference there, except providing the .so file here, right? Or if you have the dynamic library, you want to search for the dynamic library, then you can just provide this lowercase -l switch. Now in this case, I think we can even use this format, because first it looks for the dynamic library file and it links it. If it doesn't find dynamic library file, then only it links the static library. So we can even use this format in this particular case, but just to be safe, I'm going to use this particular format to create a executable file. Dynamic.out, and then I'm going to provide the object file, and then I'm going to provide the, now you can see that I don't have to recompile my object file of the main function again. Okay, I just need to link it, right? Because the linking step is only the different step, because I am going to link dynamic library file versus the static library file, but the object code of the main function does not change in this case. So I don't actually have to recompile my main function here. Okay, so now I'm going to create this dynamic dynamic executable file. Okay, so now you can see that this executable file, which is my static executable file, and this executable file is the one which uses the dynamic library. Okay, now you can see the size difference. This one has 16,824 bytes, whereas this one has 16,768 bytes. So you can see that the dynamic library, in this executable, I've used the dynamic library file. It requires less bytes, less number of bytes. It's a smaller size of executable compared to the static library. Why? Because I said that the function code is embedded inside the executable file whenever you use the static library. Whereas the function code is not embedded inside the executable whenever you use the dynamic library. Therefore, the dynamic library executable code is smaller compared to the static library. Okay, and yes, the size is not that much difference. The reason because our function is smaller, right? It's only one line function. If you had a larger functions, which does a lot of things, then obviously the gap will increase. The size will vary much much greater, right? So the point is that this one has the code in it, this one doesn't have a code in it. And how do I know that? Because I'll show you the disassembly of these ones, and that I can explain to you there once we have the disassembly that the code is. So we'll use the disassembly step, which is that obj dump one, -d -m intel -s, and then the executable file name dot assembly greater than call dot out assembly. Okay, and similarly I'm going to create that same thing for, okay, I should have put here static, and here also I should have put static. And now I do the same thing for dynamic. Okay, so we have the two assembly file, right? The static and the dynamic, and so we are going to open this once. Okay, so maybe I had done this thing earlier, so that's why it was reloading it. So this is my disassembled code, right? So this is my assembly code, which I have generated from the executable file. Now, when I look at this program, there is a function code for main, right? And it is saying it is loaded at this particular address in the memory. So when this executable file will be loaded into the memory, this will be the starting address of the main function. So let's say you could have an address, starting address could be anything, but this is an absolute address that we are looking at, right? Absolute address of 1149. Okay, so let's say this program starts from 0, right? It will start from 0, but then the absolute address will be that 1149. Now, when you look at the main function code, you will notice that there is a call to the add function here, right? And it is saying that you go to this particular address 11F1, and 11F1. Now, this is the disassembly of the executable file where we had linked the static library, the .a file, right? So when we go to this address, we are expecting to find the actual function code of add function, not the dummy reference. Okay, so when I go to this 11F1, I go to this place, and this is the place where the actual function code is included. So this is the actual object code of that function, which was actually there in the .a file, but it has been copied from that .a file to here, because we have linked the static library. And how do we know that? Because you can see that these are the parameters that it is trying to extract, right? It's basically reading the arguments that we have passed to the function a and b, and then it is actually doing the addition. And then using the stack, it is returning that value back. Okay, so this function is reading the values, accepting the arguments, adding the values, and then returning that thing back. So this is the actual function code. We can see that. Similarly, if you see the subtract function, right, the sub function, Again, it is located at this 120F, and that is what we have here. And you can see that there is a sub command that you can see, which is your subtraction command, right? But let's say if you look at the printf or some other functions, possibly, let's say we have used printf. Now printf is not included using the static library. It is included using the dynamic library. Okay. I know that because I have already looked at this code, but I'll explain to you why when we look at the dynamic library thing, the disassembled step. So when I go to 1150 is where you will find the the code for or basically the position where the printf function might be available. So you can see that this one doesn't actually have the code for printf function. It is just saying that you jump to this address somewhere, right? So you jump to this address somewhere, and this is the address where this library, glibc is the library file name, or libc is the library file, where the printf function is located or is available, and this is where you should start executing the code which is for the printf function. That is what this code is saying. And it is saying this because printf function is still coming from the dynamic library file. Okay. We look at now the disassembled code for the dynamic library. And if you go to the main function, so this is my main function, right? And now if I look at add and sub, right? So it is saying that add is located at 1070. Now I'm not expecting, because I have linked the dynamic library here, I'm not expecting that the add function code will be here in this executable file, right? So 1070 is where I need to go. And here it is. So again, you can see that I don't see the add function code here. What do I see? Again, I see just the jump instruction. Okay. So what is this jump instruction does? So what happens is that whenever you have the dynamic library that you are using in your code, the operating system keeps track of a table. And in that table, it has the list of library files that are loaded and the list of functions that are included in those library files. And where each of those functions are loaded, it keeps the offset or the address. Okay. So what it has done is it has told the processor that the function code of add from the dynamic library file is actually located at this address. So it needs to go and jump to this address, which is going to be where the address for this function code is, or where the function code is loaded, and then needs to start executing from there. Same thing happens for the sub. Okay. So sub is also loaded somewhere in the memory, but it is not included in this executable code. In short, what I'm trying to say is that whenever you use the static library files and static library functions, then the code of the function itself is included in your executable file, whereas for the dynamic library functions, the code is not included in your executable file. But the library files will be loaded when you start executing the code itself. This is the major difference between the static library and dynamic library. And as I said, there's a trade-off between the size of the file, which file case, when you use the static library, the size of the file becomes larger. So if you have too many functions that you are using inside your code, and if you are using too many static libraries, then the executable file will become very, very large. But then there is a speed in execution, right? You get much faster runtime compared to the dynamic library. Okay, so this is what the difference between these two files are. Any questions?
Hello, sir.
Yeah.
So then why is the size of .so file more than .a file of my math library?
Right. So basically what happened was that when you created the .so file, the .so file has to keep track of lot more information about that table and stuff like that I was saying, right? It has to keep track of which functions are there and what address it will be loaded, in the memory. So this one just has to have the basic object code of the functions, whereas here it needs to keep track of more information. So therefore this file size is larger, but see, we are not worried about this particular size, right? What you are worried about is the size of these files, because these are the files which you are going to actually execute. These are the files you are going to just ship it, right? So in case if you have developed your own library, then you will be supplying this library file and you will be supplying the header file. So these two files you have to provide to the whichever user wants to use your library functions. So let's say you created your own library. Let's say you created some special library for image processing or whatever, right? And if somebody else wants to use those functions, then you can either provide the .so file, or you can provide the .a file, or you can provide both of them and the header file. Any other question?
So in the disassembly code which you shown, is there any specific reason, like in this for the static file, the code is loaded after the main function and the referencing for dynamic is done before the main function, or is it just like?
Okay, good question. So the point is that see, whenever there is a dynamic linking that we are doing, right? It is always going to the table, right? The table which is kept in the memory by the operating system that covers all the functions that So this particular code, it already knows that these are the functions it is accessing, and so it is including this code over here, right? That function code comes from this particular section in your executable file. But in your static one, basically it is listing function by function, one after the other, and then it knew that okay, there is a main function, then there is a call to these functions, and then it is. So whenever it found out that the function code is to be included in the executable file, that is where it goes to the static library file and then includes it. So therefore it is coming after the main function. But there is no, like a specific reason why it would always do that. You could find sometimes that the function code could, be loaded earlier than the main function also, right?
Okay, sir.
Okay, so this is how we create the executable files, and as I said, running the static executable file is pretty simple. Why? Because as we said that the object code is already included in the executable file. So all you have to do is just do call and that executable file name, right? And because the executable file already has the function code, there is no need of telling the executable where the library file is. See, because in case of dynamic library case, the library file also is required at runtime, because at the time of the creation of the executable file, you have used the dynamic library, but that dynamic library also has to be loaded at runtime. Whereas in case of static library, there is no need to load the actual library in the memory, because the code itself is copied over here, right? So when you use the dynamic library, that is another thing that you need to worry about, is that the executable file should be able to access the dynamic library file also and get it loaded into the memory. If the executable is not able to find the dynamic library file, then also you will not be able to execute your executable file. So for example, if I try that now, you see that I'm getting an error, right? Because this library file is currently not loaded into the memory. Okay, it is trying to find it where it is available, but it doesn't know where it is available. So even at the runtime, I have to specify that where the operating system will be able to find this library file. And there are three options for that. That is what we will look at next. So how do I know that that library file is not, or how many library files are not currently loaded into the memory which my executable is looking for? You have to use what we call LDD command. Okay, LDD is the command that shows which library files are not reachable by a given executable file. Okay, so that is what we will do. So let's say LDD call okay, so my executable file is using these many library files. It is using this one, it is using this one, it is using this one, and it is using the one which I have created. And you can see it is saying that this library file is loaded at this memory address. This library file is loaded at this memory address. Okay, and this library file is loaded at this. So by the way, this libc so.6 is the library file where your printf, scanf functions are there. Okay, and as I mentioned earlier, that this is by default linked using so GCC already knows that most of the program will require libc.so, so it will by default link that library for you. Okay, but this library file is what we have created, and it doesn't know that this is also required, and therefore it has not linked. Right? Well, it has linked, but now at the runtime also it requires the path to this library so that it can be loaded into the memory. So currently it is not loaded into the memory. So what we can do? So first option, so there are three options, right? So the first option is that there is a special environment variable. And if you recall, we learned environment variable very initially, I think during the first or second lecture probably. LD library path is the environment variable where you can provide the path for the library file that you want to search the operating system, right? So operating system will look at this particular variable, environment variable, and whatever folders that you have listed here, whatever directories you have listed here, that is where it will search for the library file. Okay, it could be .so file, or it could it is a .so file in this particular case because we are looking for a dynamic library. Right. So now what I'm going to do is I'm going to create that variable, export LD. So first of all, let me tell you that it is not available. How do I show that? I will display all the environment variables, and then I will do grep LD library path. And that variable is not available, otherwise it would have displayed something here, right? So what I'm going to do is I'm going to create that variable using export command. Why export? Because export command creates an environment variable. If I just use a regular variable equal to something, then it is not an environment variable, right? So I have to export and then LD library path equal to. Now here I can actually just say dot, right? Dot for a current directory, but it will not be valid if you have a if you have a shell script that you are running and the shell script changes the directory internally, right? Or maybe you create a sub shell, right? So you say that you say bash from here, and this is my sub shell, right? The nested shell. Now in that case, or child shell. So in the child shell, the environment variable will be accessible, not a problem. But it is possible that maybe you have changed the directory there also, right? So in short, what I'm trying to say is that because the dot directory is a relative directory, right? It is not an absolute directory. We should try to provide the absolute path over here rather than the relative path, right? So we'll say pwd, and this is the path where that library file is available. So I'm going to say now export LD library path, and you will notice that there is space in between here, so I have to include that in quotation mark. So quotation mark will take care of that space thing. Now if I run that env command, and I should be able to find the environment variable. Okay, and now if I do LDD, and now you see that now the operating system tells me that yes, it is able to find this library at this location and it is available at this memory. Okay, so it is able to now find that library file, and therefore if I run my executable code with the dynamic library, then I will be able to execute without an error. But what is the problem with this method? The problem with this method is that the environment variable is only available in this shell or in the child shell from here. But when I create a new terminal window, right, a new terminal window, then that variable again is not available. Here it's not available. So again, if I want to run that program here, again, I will have to set that variable over here. So what is the solution for that? So there are two solutions. Okay, the first solution is, as I mentioned, that there are standard folders where the operating system looks for the library files, the dynamic library files, one of which is a user lib folder. So user lib is the folder which is searched by default by the operating system, where you can put your library. So what we can do is we can actually put our library file in this folder, and the operating system will find it. But the problem is that, well, I mean, it's not a good method. The reason being that this folder is actually the system's library folder, and we don't want to add a file which is actually a user library file which we have created, right? So we don't want to sort of like, create a garbage in this folder. Okay, so therefore we don't usually use this second option. It is there, but it is not advisable to use. What is the other method? The other method is that there is a folder called etc/ld/so/config_d. This is the folder, and if you look at this folder, so let me go to that. Now, if you look at this folder, it has these three files, and they are, they are having extension called conf, right? So what these conf or configuration files are, it has the list of folders where also operating system should look for the library file in addition to the user lib. In addition to the user lib, right? So if you do cat libc-conf, you will see that there is a library mentioned here. So libc default configuration is located over here, right? Similarly, if you look at any other one, then there are these three library files, library folders, right? These three folders is where also it should look for the library files. So one option is that we can create our own conf file here. Okay, we can create our own conf file here and provide the path in that conf file for operating system to look for the library file at that path, right? So we have to add a new file here in this folder, and in order to do that, you can see that the access required is root, right? This folder requires a root access, and what we will do is that we will use a sudo command. So sudo is the command that allows you to temporarily change the permission from a regular user to a root user. Okay, so this is not a permanent change to the root user, but it is a temporary change only for execution of the next command. So I'll do sudo, and then I'll do gedit, and then I'm going to create my new file, right? So I'm going to call it as mymath.conf. So this is the new file that I'm going to create in this folder. And you can see that it is asking for a password because not all the users have super user access. Okay, super user is basically root access, right? So not all the users will have the root access, but because we have created this user at the time of installation, this user has a super user access. Okay, in our in our college, when you are given a user for a server, your user may not have the super user access. Okay, so now the gedit is open, and now I can put that path which I want. And so I'm going to copy the same path. So pwd copy, and then I'm going to go to gedit. I'm going to paste it, and then I'm going to save that file. Save, and that file should ls-lt, okay, mymath.com. Now, creating the conf file only is not enough because the operating system does not actually check for these files. What happens is these files are also loaded into the memory, and the operating system actually goes to that memory location to say that which directories are mentioned in these conf files. So we have to ensure that this file, our conf file, is loaded into the memory, okay, into the memory. And for that, there is a command called ldconfig. So we create the conf file, and then we run the ldconfig command. Again, ldconfig command requires the super user access, so we will have to use sudo, okay, and then ldconfig. And once you do that, all these 4 configuration files will be loaded into the memory again, including the one that we created. Okay, so once we do this, then when you go to the new terminal window. So let me create one more here, and let me go to the our directory, host files, system UCC, and here if I look for that ld environment config variable, it will not be there, right? So ideally, it should not be able to find the path to the dynamic library of myself, but now it will be able to find it because I did mention that this is the conf file where the path is mentioned, and that conf file is now loaded also into the memory. So if I do ldd, now you see it is still able to find that path and that library because I've asked to go through whatever is mentioned in this folder as well. So without a LD library path variable, environment variable, also using this conf file, you can say where to look for the .so file. Clear to everyone? So now if I run this executable here, it should be able to run without any problems.
Sir, could we add the path directly to the legacy conf file?
Sorry, can you come again?
Sir, here we created another file for adding our path, right, sir? Sir, could we add that? Could we add that path directly to the legacy conf file?
You can add it. Yes, you can add it. But see, we don't want to corrupt. So these are the files that are provided to us by operating system or some standard libraries, right? So we don't want to corrupt these files also. I mean, we don't want to put an extra stuff in these files which are not actually really part of these files originally. So instead of doing that, we just created our own conf files.
Okay, OS, the operating system will look for the path in all the conf files, right?
All the conf files. As long as you do ld config after that, right? So once you create your file, the conf file, and then you do the ld config. So once you do ld config, all the conf file which are available in this folder will be loaded into the memory, and that and then operating system will be able to find those paths from each of these conf files.
Yes, sir, got it, sir.
All right.
Yes.
So this is how your shared library and the dynamic library works. So your static and the dynamic or the shared library works, right? So again, just to reiterate, basically what happens is that you have the code embedded in the executable file whenever you use the static library, right? Whereas when you use the shared library, the function code is not embedded into the executable, and therefore even at runtime, you have to tell the operating system where the library files are available when you are executing your code. Okay, so that is basically, this loading is nothing but is what I just explained, right? So it is just telling you that the static library file does not really require the loading of the functions separately, right? Because it is already included. Whereas in case of the dynamic library, it does require to load that object code of the referenced function separately, right? Let me cover this one last slide, and then we will stop. So in GCC, we are looking at how the source files can be converted into executables, and how can you create a library file. You link the library files with the other source code to create the executable, and so on, right? Now GCC also has something called as optimization levels. Okay, and depending on the O version or O level, O is basically for optimization, and then you have 0, 1, 2, 3, and S, right? These are the various optimization levels that you have. So depending on the number that you use here, or the option value that you use here, it does optimization of different kinds. What do I mean by that? So when you say 0, there is no optimization. Okay, so the code is unoptimized but has the fastest compile time. So it compiles as fast as possible, right? When you do the 1, it has a moderate optimization and optimizes reasonably well, but degrades the compilation time significantly. So basically what happens is it tries to see how to improve the running of the program. How to improve the running of the program. For example, I'll just give you one, one thought is that, let's say, when we looked at this static function example, right? Now in this case, what did we do is that, let me search for the main function. In this case, what we did is that we took this, we did the call, right? That means that the function code is available over here. And so what it had to do was that it had to basically change the program counter or the instruction counter, where it says that now you go to this particular address and start executing stuff, right? Now, before it does that, it also has to say whatever was done till now over here, right? It has to try to keep track of, so if you are using some registers over here, and those registers are also being used over here, right? So for example, this RBP is the register which is always generally used for parameter passing to the function, right? So let's say these values were used over here, and the same registers are being reused over here. So it is a job of the process control to ensure that the information that is used in this function is saved before you call this function, right? And then once this function is executed, then you come back over here and restore the state of that function, right? Now that obviously takes more time. So one of the optimization is that you take the code here, right? And directly take the actual function code and embed that function code right here instead of doing the call. but that, that requires some thinking by the processor. And so that is kind of the optimization things that processors can do, right? So what I'm trying to say is that there are these kind of optimizations that processor can do to increase or improve the, improve the performance of the program, right? Another optimization that I've mentioned here is the vectorized loop. Does anyone know what the vector processor is? Have you heard about the vector processor? Anyone? Okay, probably not. So the idea behind the vector processor is that instead of handling one value at a time, it handles bunch of values at a time. So for example, if you have a code, if you have array addition code, which you are doing something like this, I less than 1000, I plus plus, and then let's say you are doing C of I equal to A of I plus B of I. We know that if you have the code like this, right, normal CPU will have to go to the 1000 loops, right? And in each loop, it will be basically be able to handle only one set of values. Instead, if you had a vector processor, so vector processor could have, let's say 32 words, right? This is a single word. This value we are assuming it's a single word. So let's say vector processor is the vector processor with 32 words. What it means is that it handles 32 values at once. And so what will happen is that your loop will be basically become like this. And this value will be, let's say, I don't know, and this I will be not, so, I mean, I guess what I'm trying to say is something like this. Something like this, right? And every time this offset will change, right? So do you have 0 to 31, 0, this is in the first iteration. And in the second iteration, it will go from 32 to 63, 32 to 63, and so on. So it will handle all 32 values in a single instruction, even though it will be doing, one-to-one matching here, right? So 0 plus 0 will go into C0. It will be done like that only, but all 32 values will be in a separate vector processor elements, right? So vector processor does not have a single arithmetic logic unit. It has multiple arithmetic logic unit, and each word is taken care by the different arithmetic logic unit, is what I'm trying to say. So this is the kind of optimization that you can do, is what I'm trying to say, right? So various optimization levels are there, and depending on what you want to do, you can try to use them, okay? I mean, I think if you go more into the architecture area, then you probably need to know a little bit more about this one. For general user, I think as long as you have some basic understanding of this thing, then it's fine. Any questions?
Hello?
Any questions?
Sir, can we consider it as unrolling of loop vector processor?
Yeah, yes. You are basically unrolling a loop because you are saying that it is handling, instead of one value at a time, it is handling, multiple values. I mean, that is how the vector processors do. So what it does is it takes care of the set of values that it can, and then in the last loop, it will be basically whatever the remaining values that are left. Any other? Okay, so thanks everyone, and yeah.
Yes, sir. I was having a question regarding static library. Sir, during the time when we link the static library with the object file at that time, is the entire library's code copied into the executable file, or only the code for the functions that are called in the executable file? Only that functions code are copied.
Okay, good question. And the answer to that question is only the code of the function which you are calling. So, for example, if I would, and maybe you can try it out since we are running out of time. But what I would do to test this is you can remove the call to the sub function from here, right, in your executable file. So you can modify your file and you can just comment this line out, right? And then you can recompile this file and then create the executable and then create the unassembly and see what happens. So basically, it will only include the object code of the function which you are referring in your code only. Even this is otherwise what will happen is, let's say, for example, the standard library files are very, very large. It has a lot of functions, right? But we are not actually using all those. So if you include, let's say, some static library which has, let's say, printf, scanf, and those functions, it will only include the object code of the specific functions that you are referring in your code.
Yes, sir. Yes, thank you, sir.
Okay. One last chance. Any other question? All right. Thank you, everyone. I'll speak to you on Thursday. Well, we have a lab tomorrow, so we'll first do the lab and then on Thursday. Thanks.